Hello and welcome to this video on energy. Specifically, we're going to be talking about systems and types of forces, how they interact with energy. Now, before we talk about energy though, we're going to talk about money. Money is a wonderful way to think about energy and make it make sense to you because money is something we work with, interact with. And the amount of money you have, you can move around. You can have cash, you can have coins, you can have it in your checking account, you can even have it in the stock market if you really trust that. And as long as the time frame is relatively short, you can move between them fairly easily. You can go from dollars to coins, no problem, and then you could go over to your checking account, you could invest that in the stock market, then change your mind, go back to dollars, and then drop it in your checking account, and then back to dollars again. The point being, you can move around between these different forms of money fairly easily, and the total amount of money you have doesn't change. If you have $35 in coins, that's the same thing as $35 cash, the same thing as $35 in checking account, that's the same thing as $35 in the stock market. Moving it around is fairly easy, and there's more forms of money than we've talked about here, but that's the general premise. As long as you keep it contained to things you have direct control over, the amount doesn't change. The issue is when you start using that money, spending it. Maybe you start buying things, maybe you buy video games, a car, or supplies for your car like gas or food. As you start spending money, the amount of money you have decreases. Now, if you spend enough money, you're going to run out of money. You'll have no more money in your control, in your system. So what you need to do is figure out a way or find a way to get more money. Now, maybe that involves going out and doing hard labor. Maybe that involves going forth and getting extra supplies. But at the end of the day, somehow someone's going to have to do some work to add money. This will increase the amount of money you have. By doing work, you increase your amount of money. By spending it, you decrease it. And this is how energy works. This is the general principle of how we make energy work. Now, the difference here is instead of money, it's types of energy, joules. But the principle's just the same. You have kinetic energy, you have elastic potential energy, you have gravitational potential energy. There's various other kinds of energy. And typically, you can move between these fairly easily. You can have an object slow down as it goes up a hill. You can have it go down the hill and speed up. You can have it go into a spring and compress the spring. You can have it shoot off the spring and go up a hill or go back to moving. Moving between these different types of energy is fairly easy. Now, if you want to increase the amount of energy in a system, you need to do work. We talk about this as positive work. By doing positive work on a system, you increase the amount of energy present in the system. Likewise, if you do negative work on a system, you remove the total amount of energy. You decrease the amount of energy present. By moving from one form to the other, you can change this around. With this kind of mind, you have to be very careful when you pick your system and how it works. So let's take some look at some examples. For instance, in this hill example here, we're just looking at the ball and there's no friction going on. At the start, since we're just looking at the ball, nothing else, just zoom in on that ball. The only type of energy it has is none. There is no energy to start. This ball was sitting in the middle of an empty void, which is what we're saying effectively. There is nothing here. There's no movement. There's no gravity to really give it gravitational potential because that's not part of our system. There is no springs, nothing. But at the bottom of the hill, it has kinetic energy. In this case, because we did not include the Earth as in our system, because we did not say the Earth was part of it, gravity does work and increases the energy on the system. In other words, gravity does positive work and increases the mechanical energy of the system. Now, a common way to represent this is with an LOL diagram. This is not laugh out loud. LOL tells me that I'm drawing two bar graphs and tell me how my energy system changes. So for the first L, What energy do I have to start? I have no energy, so nothing here. The O represents my system, what's in my system, in this case, the ball and the note without any friction, and tells me whether or not there's work being done in the system or not. In this case, gravity's doing it, so it's going to add energy. Work done on system increases energy. That way, at the end, when I look at this ball at the end, I can go, okay, well, now there's energy. What type of energy? Well, it's moving down the hill. It's going to have EK. And you'll notice how we went from no energy whatsoever to having EK. This is how the LOL diagrams work. It helps us think and go, okay, how does it start? How does it end? How do we get from point A to point B? Let's look at a slightly different example. Let's look at a different system. In this case, we're going to include the Earth in our system. We're going to say that the Earth is part of our system. Now, in this case, this ball at the start has no EK still, but it does have EG because it's above the ground. It is some distance up. So we say that there is some amount of EG. You can make little sections, however you want to delineate. There you go. Now at the bottom of the hill, at the amount of energy we have is going to be the same. There is no, because we've included the Earth, there is no forces acting on the system, especially because there's no friction. So because the amount of work we're doing is zero, the amount of energy is staying the same. It just changes forms. In this case, we now have EK, but we have no EG. In other words, the kinetic energy came from the gravitational potential energy, or the gravitational potential energy changed forms, just like the money changed from coins to bills, from gravitational to kinetic. Let's talk about the third situation. In this case, we have the ball, we have Earth, but we also have friction working on it, doing work. Now, there's two ways we can talk about it. We can talk about friction being in the system. We'll call that A, and we'll do that in blue. And we'll talk about it, friction not being in the system and doing work, and how does that look. We'll do that one in red. We'll start with A first. A, friction in system. In the beginning, we still have this EG. And that's the only type of energy we have. On the other hand, we also know that we will eventually have EK because it's going to be moving at the bottom of the hill, and there's going to be something done by friction. But at the start here, just EG. Now at the bottom of the hill, we have no more EG, but we do have some EK. Not as much EK as we had EG, because some of that energy has been influenced by friction. Friction has increased the heat of the object, has made some sound, has dissipated this energy some way. You'll typically see this as E thermal or E dis, short for dissipated. This energy, so to speak, is energy that we can no longer change around nearly as much. In the money analogy, this is putting the money into government federal bonds. Yeah, sure, the money's still there and still around, but you can't get it back. It's no longer accessible to you. It's no longer a bit of money you can use. Eventually, maybe we might be able to, but given our current technology and our current abilities, we can't. On the other hand, we can talk about situation B, where the friction is acting on the system. At the start, we still have the same amount of EG, because we're at the same height we've been every time. But at the bottom, because all we care about is the ball, the Earth, and the friction is doing work, there's going to be energy leaving the system. Friction will do negative work on the system. Up here, there was no change in energy because there was no work being done on the system. No work. The EK in this case will be less. It will be just like we said before because some of that energy has been dissipated, or if you prefer to think about it this way, the amount of work done on the system by friction is negative. So we had 4 bars here to start, now we have 3. We have less energy because negative work was being done on the system. Both are fairly valid ways to think about it, but understanding the difference between the two ways of thinking about it is just a matter of perspective. If you want to know how much energy is dissipated, perhaps you leave the EDIS in and calculate it. Or maybe you don't particularly care. All you care about is there work being done, yes or no? And at that point you can compare EG and EK and go, are they the same, are they not? This brings us to our definitions. We talk about an open system and a closed system. An open system is a system that we are looking at for energy where the total amount of energy changes. This tells us a net work is being done on the system. On the other hand, a closed system is a system of objects where the total amount of energy is constant. Now, this means that there is no net work on the system. However, this doesn't mean that your energy isn't changing forms. You can still go from kinetic to gravitational to elastic, but the total amount between all of these is the same. To put this in bar graph terms really quick. Here, in an open system, the number of blips or blocks of energy will change as they're added or removed, representing work being done on the system. In a closed system, the total number of blocks does not change. They might move around into different forms. They might change around into different forms, but the amount of energy, total amount, is the same. 4 blocks here, 4 blocks here. This is different between the two of them. Going back to our previous example when we're talking about the two different ways of talking about it, if friction is in the system, it is a closed system. So A, which is the blue graphs, represent a closed system because the total amount of energy in the system we are measuring does not change. On the other hand, if we look at the red graphs where friction is not in the system and is doing work on the system, this is an open system because the total amount of energy in it is changing. Now, you'll notice that when I went from example 1 to example 2, all I did was change my system and suddenly gravity wasn't doing work anymore. There's a term we need to talk about, conservative forces. These are forces that can act on a system without changing the total energy of the system or dissipating it. These are forces that when they act on a system, there is no dissipated energy. There's no energy turned into a form that's hard to get back. Another way to think about it, the more practical way to think about it, is these are forces or objects you can include on the system at the level we are at in this class. The only type of conservative forces we're going to talk about this level are Fg and Fs, force gravity and the force of a spring, which directly relate to Eg and EEL. Because these forces have a direct and easy way to calculate their energy, we can put them in a system, remove them from a system at will. Again, the only forces at this level that we will consider conservative forces, the only forces that can act on a system without dissipating energy somewhere, are force gravity and the spring force. On the other hand, you have your non-conservative forces. Your non-conservative forces, when they act on a system, the mechanical energy of the system changes. If you do positive work, it increases the energy. If you do negative work, it decreases the energy. These could be any other force, friction, applied, normal, anything else. These forces, when they act, will change the amount of energy. Now, there might be another force canceling them out. If you have friction to the right and applied to the left, but they are equal in magnitude, friction will remove energy at the same amount that applied is adding energy, and the system will be considered closed. There will be no net change to the amount of energy in the system, but each of them are trying to do it individually. You have to look at them at the micro or macro scale, depending. We'll talk more about that in future videos. Again, any force that is not force gravity or force spring is what we consider a non-conservative force. We'll talk more about these later, but the shorthand that I tend to use is that if one of these other forces is acting, there's going to be dissipated energy somewhere. If you are applying a force, you're dissipating energy in your body. You're generating heat, you're generating a sweat. If your car is burning gas, the heat is generated there, and that heat energy is impossible for us at our current level to get back. And I'm not talking physics level, I'm talking technology levels. Anyways, thanks for watching. Have a good one. See you next time.